Hey you guys, what's up? We're on page 226 and we're going to finish out this activity here. We're trying to use all the information that we've accumulated from the last couple of lessons, the last couple of pages. Let's start with this. Do you have your perpendicular bisector construction patty paper? Maybe you did it the other way where you just folded a line segment exactly in half. But the point is, make sure that you have those because I'm going to ask not only to describe, but also to actually physically create them. And we're going to use perpendicular bisectors at one point. Let's get into it. Knowing certain properties of each quadrilateral makes it possible to construct the quadrilateral given only a single diagonal. So that's the line that connects opposite corners. In fact, vocab word that students seem to struggle with, diagonal, highlight it. All right, describe how you would construct each named quadrilateral with the given diagonal. Once again, there it is, and there it is. So a parallelogram. For a reminder, a parallelogram, two pairs of parallel sides. They happen to also be the same distance, like the same length. These two are the same length, these two are the same length, and so when we create a parallelogram, we're looking for that consistent measurement. Okay, parallelogram, WXYZ, given the diagonal WY. So I guess step one, draw WY. All right, call that first. And I'll do this over here on the side, or maybe you want to flip it depending on your book. So I'm going to draw, it's got to be a diagonal, it's got to be slanted. So I'm going to just draw like a diagonal line, like a slanted line. Label the end points. There's W, there's Y. Okay. Now, step two is to find the midpoint, all right? Find midpoint of WY. And you do that using the perpendicular bisector. If you have a perpendicular bisector, find the midpoint of WY using perpendicular bisector. Right? So what I had created from before, this is going to be a little bit challenging because this is relevant to the previous examples and my line here is different. So the trick I'm going to use now is actually the fold it technique. And I might need a new piece of paper, a new piece of patty paper, but whatever. So here's W, label. Here's Y. Draw the little line, like sketch it. You should try to be as accurate as possible. But then you're going to take W and Y and you're going to fold them together. So the patty paper makes it pretty easy to do. If not, the other trick is to use the circles, which, you should practice using the compass with the circles. That is a skill in geometry that you need to know. But right now, we'll be all right. By taking this and folding it exactly in half and then opening the paper back up, I can place it. I flipped it. You didn't catch that. I flipped it around, so it's actually upside down. And I can put a little mark right here, lining it back up, and put a little mark right here to mean that this is the midpoint. You saw it kind of like leave an impression on the paper. Okay. So by knowing that, remember in a parallelogram, the diagonals are cut in half. They're bisected. So that's what I want to do is I want to actually bisect this diagonal. And now I just need to construct another diagonal that's also bisected and then connect the ends. So step three, construct or make, right? Make a second diagonal. Let's call it XZ. I'm using that because of the letters up there. Construct a second diagonal XZ that is bisected. I'm going to label this E, right? At E. And then step four, connect the outside dots. Outside dots. W, X, Y, Z. W, X, Y, Z. Okay, so I already have this piece of paper. I've already got the one that's set up. In fact, I'm just going to recreate what I had done with the previous page's questions. So I know that in the other paper, when I'd used this with the previous examples, which is why I hope you save them, that I have this crease along the line segment BC. So if I use this crease to center the crease exactly on point E, and then I make a dot. I'm going to try to make it have some tilt to it, make it be interesting. And then put dots at BC. There they are. Now I'm using BC from before, but I should change the letters around to make this be an X and make this be a Z. Here's my other diagonal. I think my choice in this moment is to use dashed lines because diagonals shouldn't be solid around the shape. And then actually connect the corners, all right? WX, XY, YZ, and ZW. All right, there it is, parallelogram. Because of the way that the diagonals are bisected, both of them, this line and that line are the same length. This section EX and this section EZ are the same length. Then actually what that means is that XY, 3 spikes, and WZ, 3 spikes, are in fact parallel. Give them a little arrow. And that also then means that WX, 1, 2, 3, 4 spikes, and YZ, 1, 2, 3, 4 spikes, are also to themselves parallel. So double arrow, double arrow. There's a lot of notation there. That's some of the high-level notation that we should be using. I'll forgive you if you just use highlighters and highlight the lines that are actually parallel. So that line is parallel to that one, and I don't have an extra highlighter for this part, but I'll have more highlighters for part B and part C. Thank you for watching part A. Stick around for part B. Thanks. Bye.